Okay. So today we are going to look into quality management. It's a basic way for us to move forward is to see how these evolutions of quality, and hence we look into how can we actually differentiate between one concept or one theory, what are their philosophy behind it to another. Before that, I want all of you to please uh, just take your own attendance. So if you go to the e-learning just now, you can see the attendance of the 2nd of May. And then eventually, just take your own attendance. So if you are not having that before, so you just click to this QR code and then click your attendance. I give you 10 seconds for that. I have to stop the video because it seems that when I use the video, the internet lag a bit for my side. I'm not so sure about your side. All right. Just take your own attendance first for this 10 second. All right. So for this outcome, we'll see into the evolutions of quality, how the quality management styles differ from one another, who are these quality thinkers, traditional versus modern quality management, element of total quality management, Six Sigma, the MAIC concept. Ada twist ke? No, just I thought of giving just a questions, but however, never mind. We'll see that quality actually starts from military. During the World War II, then you see that as the quality evolved, the pre-World War II, we have isolated economics, which only focus on what is quantity, how much, and how is the profit look like. However, during the World War II, this is the period of change from quantity to quality. So it begins as women workforce go to the field to replace the men who are in war. So basically, then they come up with 1990s. They focus on quality. Right. So this is a history of manufacturing. The first lecture from Prof. Christoph Rosser in June 4th, 2014. This is the history of manufacturing. It's been released, okay, on the mechanization and energy sources. How Egyptian potter wheels been used to transport the statue, and then the Egyptians' lathe machines been used. All these are based on the sculptures on the wall of the pyramids. And then Roman flour mills been sculptured also in the walls. It's all this has been taken, and they say that this is based on the Roman flour mill. And then this is the Persians windmill. The Persians already what is so called invented the windmill. And then Chinese water mill. It's also been invented during the prehistorical. There will be evolutions of the manufacturing. And Roman sawmill also been illustrated at that time because of there's no what we so call cameras. They sculptured it on top of whether it's in papers or in let's say walls or something, or in stone, or perhaps in like copper templates. So all this actually a prehistoric manufacturing in their eras. So we see that there are mechanizations and also how they harvest the energy sources. And then the impetus of this evolutions of manufacturing came up the steam engine in 1775. This is the first most what we so-called effective steam engine from James Watt. And then Soho Manufacturing of this Matthew Bolton gave us a production of what is the electricity look like. And then production of cylindrical iron made by John Wilkinson, which actually give us a huge impact or synergistic effect to the electronics and electrical, because of the steam engine is impetus to the manufacturing in advanced level. And then we see instead of basic manufacturing, it goes to the precision manufacturing. This is where we see there is a relevance of flexibility, whereby in 1908 to 1927, Henry Ford actually manufactured the what is so called on the road vehicles. That time they also call it automobile. So this is what we get from the first generation of Ford Model T. And then Alfred Sloan come up with Chevrolet. Okay, Chevrolet had long become one of the icon last time. Okay, this is where the relevance of flexibility, how they change based on what are the demand, what is the requirement based on legislations and etc. Then came the lean productions in 1950s. Then Edward Demings came. Then we saw the productions. They only produce what that we need, when you need it, and in what quantity required. So Ford and Toyota production based on what is what we call it lean productions. They produce based on what you need, when you need it, and which or what quantity that you are required. So at that time, it is also, as we already know nowadays, as lean productions. They use the 5S and then Chakachaku, Jimba, Genchi, Jidotsu, Just in Time, Kaizen, Kanban, Muda Murai Muri, Pokayoki, and SMAT. All this actually had been practiced in during this era of lean productions from Ford and also from Toyota production line. And from Earth to the space race, to X space and beyond. So we also know in USM we already have Kasa X. This is anak tiri pada X space lah. Alright. Because if we are to launch X space here, then I would say that the whole campus been used for only for launching platform lah. And then all of you don't have any class lah. All right. So basically, this is all the evolutions of manufacturing, and who are the person behind all these things to become a reality. So we go back to the history of quality paradigms. Last time we only built based on the customer requirement. So basically, if the customer wants this, then we craft it and then design based on what the customer wants. And then came the mass productions, where these mass productions, then everybody needs to look into the quality by inspections. This one, it focus on design and building the product for mass productions. And then they produce large volumes that will reduce costs, increase the profit, and then push the product to the customer. This one actually, they just get the good one and throw away the bad one. This is what we try to avoid. In a total quality manufacturing or customer-driven quality paradigm, potential customer, they determine what to design, what to build, and based on their requirement. And of higher quality will be obtained by preventing this problem. Preventing problem. What kind of problem? Actually, it depends on the feedback from the customer themselves. Why do organizations compete? Okay. Most common competitive measurements is based on, of course, quality. We want to see which one has the best quality of all the manufacturers. And then cost. Which one is the cost effective? Because if we want to purchase product, we have to ensure that the cost is to the minimum that we can buy, fit to buy and fit to the function. And then delivery time. Of course, if we want the product or the purchasing, we have to have what is the delivery time, the lead time. How about the accuracy of the delivery? Other measures such as of course, safety, and it contract back to the legislations, whether the government allow or not, because safety is number one. So employee morale, if this company actually boosts up employees' morale, or degrading or demotivating their laborers, if they are using child laborers or not, then that one is also things that we have to consider why the organization compete. And of course, product development. Because people are already advanced, they are very choosy, they want a very, everything must be there. Time to market also must be in an innovative products, things like so, pleasant to the eyes. So all this give motivation for company. How can we ensure that this is of passive or reactive, or proactive or preventive? So we have to set the product in acceptable quality levels. We have to make inspection to ensure that the product comply. It must comply to the specifications. And then on the preventive measure, we have to ensure that the product quality and the processing is designed in such a way it is of a good. Somebody speaking? Sorry? Not so sure who is speaking. Okay. Or the identity of the source of variations. That one go back to the Taguchi. Source of variations, or whether it's robust or the conditions variations. Or if we can monitor the process performance itself from the raw material to the end product. So these are all the contrasting approach whereby we see how can we control the quality. And then back in 1970s on quality management style, the American companies noticed that there are dramatic loss of market shares. Because of this, then they also look into who's the competitors. The competitors are Japanese, okay, in many product areas, especially in automotive and electronics products. So this is because Japanese products are superior in quality and lower in price, and Japanese company already using the statistical process control charts to improve their quality and adopt the quality management. So, in contrary, the US approach on this quality was not employed. Rather, they push on the quantity, and the companies adopt without the bad one and keep the production rolling. So, this basically gave a distrust and argument over contract of the plant shutdown and also the loss of workers or jobs. So workers need to be blamed for poor quality, and the management has complete disregard of this quality responsible. So basically all this actually give a disgrace to US companies when they see how the competitors such as Japanese could accelerate in the productions and also on the market. So, according to Demings, only 15% of the quality problem attributed to the workers, while 85% is due to the processing. Uh, the processing can only be changed by the management decision. So, however, they may say 15% actually based on the workers. So it's changes been made that the US company need to regain their positions. So what they did is that they reawakening the US industry for the need of better quality rather than just without the good one, and then the bad one just throw it away. So the pioneer of quality thinking in 1920s onwards is basically again this Karo Ishikawa Taguchi. And however, US company, although they are quite late in determining the quality, however, they are in par in 1980s actually. Based on these gurus, Schwartz, Edward Demings, Durance, Philip Crosby, these are all the gurus, okay, quality gurus of the US company. So Walter Schwartz, pioneer of modern quality control, recognized the need for separate versions of assignable and unassignable courses. So for assignable courses is basically it's inherited errors. Okay, inherited errors in the processing, in the product itself. So on the materials, on the raw materials. So it's basically from what is inherited from the raw material, the processing, and also from the early machines being used. However, for unassignable courses, basically we already have two types, okay? So two types of unassignable courses, random and also on specific errors. So here founders of X bar are charts. Basically X bar, we know X bar is a mean value and R is a range value. And then he originated the PDCA cycles. You plan, you do, you check, and then you act on this on productions. Perhaps he's the first to integrate this statistics, engineering, and economics. Okay, so this is Walter Schwartz. So he defined the quality in terms of objective, i.e., the quality of a thing independent of people. And subjective quality is basically quality is relative to how people perceive it or how people value it. So this is what Schwartz cycles, PDCA. You plan, you do, you check, and then you do the actions. And then second of Schwartz students is E.W. Edward Demings. He works under Schwartz at Bell's laboratories. He also helping a Japanese company to apply sure statistical process control quality. So he developed 14 points to help the company. And then he attempt to make a clear roadmap for the management so they understand what need to be done, who is responsible. He make it possible whether to do the improvement on the workplace, and he actually impacting upper level management involvement and also on leadership. So Deming chain reaction, you have to improve the quality. You decrease the cost by less reworking, fewer mistake, less scraps, and then productivity improves and achieve a greater market shares and provide jobs and more jobs to other people, and you can survive in the business. So these are the Deming's 14 points of management. You have to create constancy in the purpose to improve quality, adopt new philosophy, stop pretending, depend on the mass inspection, and the practice of rewarding business, constantly forever improve the system, and modern training, modern methods of supervision must be employed. Okay, drive out fear. Do not let the workers in fear all the time because they will not speak. And then break down barrier between the area, staff area, eliminate the numerical goal, eliminate work standard, remove barrier that hinder the hourly workers, institute a rigorous program for training, and then construct top management to push for every day. However, these 14 points have a deadly disease or pitfall for this management on the quality. Lack of constancy, because it's very, very difficult to emphasize on the short-term profit, and then evaluate performance because they always do the training. So the reviewer need to be done all the time. So then again, it use money. Mobility of the management, then running the company with visible figures alone, excessive medical costs because they are stressed, and legal costs because people know already what's their right, so becoming excessive legal costs. Then came Feigenbaum. He stated that if we are developing a total quality control system of managing the entire value chain connecting from supplier to customer, if you want to find out about your quality, go out and ask your customer. So this one, quality control staff need to facilitate. Of course, it's been actually practiced until up to now, because whenever you are at the supermarket, then you'll see some of these promoters actually as a facilitator. They give you like, a flavored Maggi curry, Maggi goreng, Maggi new flavor, Maggi Penang or something like so. And then they ask you to, okay, test this one, test that one. And then they are making up the, statistical on based on survey. So this is what Feigenbaum concept of total quality control based on customer. And then Philip Crosby is saying that quality management advocates are consultant, but quality is free. So he come up with 4 absolute quality, which include, number 1 is quality define conformance to the requirement. Number 2, system of causing quality is prevention. Not appraisal, always appraisal, good, but you have to prevent. And then the performance standard to zero defect is not that is close enough. Zero defect, no one any close enough. Or even the measurement of quality is the price of non-conformance. It's the price of PNO, PNC. So Crosby approach of this 4 absolute quality is do it right the first time. Zero defect. Okay, do it right the first time. Preventive actions. No corrective actions. Of course, when you do the preventive, then you have to ensure you must also have the corrective. insist on the zero defect. Because some people, they are two factors of mistake: lack of knowledge, lack of attention. So, lack of knowledge, give training lah. And then lack of attention, then personnel need to commit to excellence and attention to details. So PONC basically it suggests that a measure of a quality is how much is spent to correct the quality problem. When we have a non-conformance, it's estimated that 20% for product, 35% for services. It make or add up to the cost, to the actual cost. Okay. So price of conformance is actual cost to the produce. If zero defect, then we have 3 to 4% of sale price. That means we actually save on no repairing, no mistakes been done. Okay. So Philip Crosby said the cost of conformance at all level is reduced with increasing prevention levels. So if it is of a good quality and a good preventive measures, then of course the quality becoming high. But again, the cost of conformance, of course you can, because of the quality is good, you can increase the price. So it's a good thing. Okay. However, Crosby also had a downfall because of outgoing products contain deviations from what is been published. The one that is deviates from what has been published or agreed to the requirement. And then the company has extensive corrective service network to keep the customer satisfied. They have to do corrective every time. So the warranty period is longer and etc. So whenever this happen, the management normally denies. Okay. Normally management say we don't want to know about all this. So that's why this is a Crosby symptom of troubles. So he come up with 14 Crosby step for quality management also. Okay, so management must be committed, dedicated quality improvement team. That's why we come up with who wants to do the assurance of the quality. Then they come up with the Department of Quality Assurance, and then measure the progress of the quality, track what is PONC, create quality awareness week perhaps, or plan for zero defect months or something, do the corrective action at the root, and then eventually zero defect day, set the goals, error cost removal, recognize the good work effort, create the quality council, and then repeat the process to improve. However, this repetitive of this training is excessive. Kan? Again, people might want to opt for what is the better way for us to look into this quality. Then came Joseph M. Juran, who contributes Juran Trilogy. Okay, quality planning, quality control, and quality improvement. So this is what Juran's been working with. He improved Japanese quality. He works with US to work on how can they change their perspective. So he said that you have to have a quality planning, quality control at the process and also during the come out, and quality improvement over the time. So the next is Karo Ishikawa. He developed a concept of true and substitute quality characteristic. True characteristic based on customer view, and the substitute characteristics are producer view. When we talk about this customer view in our statistic, we call it as alpha. So those who remember when we do the statistic, we have alpha value, and then this one is the beta value. What is producer's thing? Beta value. So alpha and beta value. So he advocates 7 tools like fishbone diagram, Ishikawa fishbone diagram, if you still remember. So advance of quality circles like workers quality team, respect humanity, respect humanity. Okay, there will be like a full responsibility across the management. And then next is Taguchi. Taguchi. Last time in EMT 212, we have a Taguchi method. Taguchi method of say how can we look into loss functions. Okay, so he came up with quality loss functions. Okay, and then the design of experiment. Design of experiment, Taguchi stated you have to identify what are the variables, key variables, reduce the variations on important variables, open up the tolerance on unimportant variables. The attention is quality as a design issue. Okay, it's a system issue, not just manufacturing issue. So he stated that this robust design based on consistency, functionality products, rather than if we are to tighten the tolerance or using more expensive materials for productions, and quality are measured based on performance. Okay, so he stated that loss increases as the product quality shift away from the target value. Of course, if we shift away from the target value, then we have lost a lot. However, using the Taguchi method, instead of losing a lot more, if we are using this curve, we use this robust functions. So we just use the square here, then we can use those parts. Okay, the loss only happen here. Okay. All right. However, using this Taguchi, we have also the upper specification limits, right? So what happened here, okay, is exceeding expectations. Normally, Lamborghini, like Ferrari, they are using tailor-made automobile. They are exceeding expectations. So this is where the what we so called luxury products, where the production is at this upper specification limits, we call it a luxury products. Okay. Okay. These are the 7 tools in quality control or in SPC. Okay, we have histogram, Pareto charts, check sheets, defect concentration diagram, scatter diagram, cause and effect diagram, and also the control charts. This one will be detailed in lecture 4. So I will not show again because last time we also looked into some of the 7 tools. Some of you might have encountered this histogram or even this one, scatter diagram, or even this checklist, checklist diagram. However, maybe the cause effect diagram, some of you might have done it, some of you have not. Even the Pareto charts, some of you, those who engage or learn in the lean manufacturing, they also look into this. This Pareto and also the cause and effect diagram. However, for control charts, I will detail through on these control charts. Okay. And then how to use the Six Sigma and this Six Sigma procedures. I will just go through very fast with this one. Basically, Six Sigma is the MAIC. You define first, you measure, okay, and then you do the what we so call analyzing. and then improving, and last but not least, we control. So these definitions, you define first what you want to do, or what is the needs, what is the requirement, and then we measure how much data that you need, how do we process the data, how do we analyze the data. Okay, the process of analysis is you have to come up with what, why, which, how, who, where, why, how, kan? Those are the WH questions that you have to ask yourself on the process of analysis. And then you can identify what are the main factor, the key factors. You say y depends on the function of x1, or y function depends very much on x2, and etc. up to how many I or n that you want to do. And then during this root cause analysis, you have to use cause and effect diagram. So this cause and effect diagram resulted from the brainstorming, because otherwise you will not know what if. So you have to identify and hypothesis what are the term that you want to use, why we use this based on the hypothesis. And last but not least, we have to evaluate and validate. So improvement, basically, based on the analysis, we prioritize what are the improvement that we want to implement. Generally, we try to, of course, some of the improvement or solution, reduce the defect or reduce the customer dissatisfaction, because we don't want customer to complain. Or perhaps we reduce the variations, because if we are talking about profit, we want to have a good quality product and then increase the process efficiency, and etc. So all these are priority that we analyze if we are to look into what are the most likely improvement that we want to implement. Okay, so improvement can be done in such a way that it is in terms of processing techniques, okay, process mapping, FMEA, Pareto, criteria matrix. And then the purpose of that is for us to control, okay, to maintain, to control the performance in such a way it follows the requirement. So we develop the control plan, and then take on who is responsible, who is the owner of this what we so call this processing. Then try to look into who can actually engage the team for this Six Sigma. Okay. And again, we cannot run with standard operating procedure because we want to repeat and then produce the same thing to make it lesser. So everybody who are new learner who just came to the institution or to the production line, when they follow the SOP, then they can reproduce, and then basically it's repetitive. So basically for the newcomer, we just need to ensure the training is there, and then we have to ensure that there are responsible people who give training requirement. How are we going to do the corrective action if something is not right? Okay, so why is control step necessary? Because of human resist to change. Because of course, those who just came in, they have a new idea. So the old management saying that, hey, this is not normal to our company. So they actually resist. Okay, resist to the change. They are comfort with a previous method. There are absence of SOP detailing on how can we engage the method that very efficient. Or perhaps inadequate process performance monitoring. Of course, all this need to be monitored by supervisor. So that's why this control step is necessary. So this is if we given, let's say, what is the customer want, then this one perhaps this is what being proposed by the marketing department. Said that we want to make something like new product for this kindergarten swings, and this is what been specified by the product request. However, senior designer design in such a way that it is you have to hang it somewhere at the trunk, and this is what been produced by the manufacturer. The manufacturer, okay, they hold it at the trunk there. However, the swing cannot go in because then it's hinder from the swing to swings. So they come up with all sorts of solutions. So as used by the customer. So they just cut off the tree trunk so that somebody can play these swings. So what the customer wanted is like hang a tire on top of the tree and then use it as a swing. This happen if there's no good communications between each department. Okay. So bear in mind, if we want this not to happen in our department, we have to communicate. We have to communicate well, and we have to make sure that everybody understand what are the purpose, what are the yes. Somebody speaking?
No, do not use it. Give me time, then I'm done.
All right. Can you mute your speaker, please, if you are to talk to each other? All right, thank you. Okay. So this is what happened if each department did not talk to each other. So like in research, if we did not talk to each other, we do not know what others been doing. All right. Okay. Okay. Type 3 words that you remember from this lecture in the chat box. Okay. I've been talking like 1 hour now. What do you remember? Okay, let me check the chat box. What is the attendance password? Oh, Angkasa X. Hari ni tak ada password Taguchi quality Angkasa X. Okay, Angkasa X becoming viral in USM. Okay, control. What else? X space. Right. Okay. Safety. Safety. Taguchi quality manufacturing, quality planning, control and improvement. That is Juren. Okay, analyze. What else? WW2. Iqbal. WW2. Ingat Okay, symptom, communication, control, manufacturing. James Watt. Electric. History of quality control. Swing. Somebody ingat swing. Talk to each other. Don't talk while we are still in the teaching mode. And root cause analysis, quality improvement, quality control. Yes. So these are the evolutions of quality. Lagi tak ada? Some more. What do you remember during this 1 hour session? Develop control plan. Vernon. Control charts. Okay. Kori Ishikawa, not Oshi. I'm going to dream about quality tonight. Okay. Okay, scatter diagram. Oh, okay. Six Sigma. Oh, of course, Six Sigma. Those are the words at the back. Normally people remember the first slides and also the back slides. Analysis, TQM. All right. Itu je. Crosby, symptoms of trouble. Going back to the Crosby, what are the symptoms? Kan? And then Crosby having Durance. Okay, Durance. Somebody told me about Durance. Okay. And so the quiz actually on this trainings. Ada lagi nak jawab. Okay, I give you some time, some more. Because some people might think of something else instead of what been taught in the class. At least you remember and you are not sleeping. For those who come up with all this, there being 14 points to the management. So all this great, ensuring that, of course, you listen to what I've been telling you all on this TQM. So we actually, it's good for us to know who is the gurus who actually come up with the ideas of quality, because then it's emulate to how can we look into quality based on previous understanding. Okay, some people already done that, and then we come up with like lean manufacturing. Kan, some of you already in the lean manufacturing class, which is quite good. It make the learning faster. But some of you have not yet enrolled for the this lean manufacturing class, so I would suggest lah, if you have your own passion on it, you enroll with it. All right. Okay. So with that, I will leave you another hour for you to think through for this quality. At the same time, please make sure that everybody get the textbooks. Okay. Kalau you browse through the internet, you can also get the what we so called free textbooks on this quality control. It might be different. Besterfield is not the best, but you can use other different textbooks from other publisher and other writers also, no problem, because the gists are the same, the content are quite similar, and how can we calculate the quality based on quality control is more or less it's been used. Okay, like in statistic for engineerings, and scientists from Navidi McGrew-Hill also had quality on it, so you can use that book also, EMT 211. The application is there. All right. So with that, I thank you very much. So I hope that we can see you next week. Monday ada kelas? Oh, tak ada. Let me check first. Monday cuti Holiday yang di Pertuan Agong. So I do hope that you use these 4 days. So all the best. Okay. Public holiday. Everybody say, oh, public holiday. All right. So I'll see you next Thursday. All right. Okay. All right. Thank you very much. Okay. Bye bye. Have a nice day ahead. Good weekend. Welcome.